Hi everyone, and welcome to week 2 of subject 40321, complex problem solving, where complex problem solutions are defined as unknown and unpredictable. Before I begin, UTS FEIT would like to acknowledge that this video was shot on Gadigal Lands. Please click the drop-down menu here for a transcript of this video. In week 1, we introduced and defined what a complex problem is and why it is distinctive to complicated and chaotic problems. We agreed in our face-to-face session that complex problems are difficult to solve, as there is not an already defined or unknown solution to them. Last week's videos also discussed adopting the design thinking approach to solving complex problems. If you will recall, we discussed the design thinking process. Design thinking includes 5 steps. This week we focus on step 2, problem definition. Here the information collected from the empathise stage is analysed and interpreted. This allows reflection on the problem, helping to create a plan. This video is the first of a series of 4 videos, providing you a toolkit for complex problem definition. It will focus on critical thinking and its relationship to complex problem solving, and most importantly, complex problem definition. Videos 2 and video 3 will focus on value-based thinking and systems thinking respectively. While our final video for this week will combine all 3 videos to provide a toolkit for complex problem definition. By the end of this video, you should be able to identify key characteristics of critical thinking, understand what critical thinking really is, and reflect on the skills you think you'll need to apply critical thinking to complex problem definition and solving. So what is critical thinking? Socrates, the ancient Greek philosopher, famously said, "An examined life is not worth living." This statement is sure to resonate with engineers and engineering students. The one thing that all engineers have in common is a desire to examine and design solutions for an aspect of life, a problem or a practice. One perfect example is when NASA made a decision which led to the Challenger disaster. Several practices were put in place to avoid a similar catastrophe. One could argue these align with Socrates' famous saying. But Socrates was not just referring to the examination of the world. He was specifically calling for an examination of one's own way of life, one's own way of thinking, and one's own way of thinking about thinking. Sure enough, 17 years after the Challenger disaster, NASA had an identical critical thinking failure which led to the Columbia disaster. Yikes. A lot of people died unfortunately, and it was an absolute disaster. Coming back to critical thinking, my favorite definition of critical thinking is presented by Daniel Flage. Flage in 2003 argued that critical thinking is simply careful reasoning. There are many other definitions of critical thinking. I have provided them in the bibliography under the section Critical Thinking. You might be asking yourself, why critical thinking? Illustrated in this image, recent research looking at the economic and social conditions affecting future engineering employment in Australia demonstrates the rapid growth in demand for critical thinking skills over the last 3 years. Also, last month, in her keynote at a conference, the general manager of Microsoft in Denmark insisted that she considered critical thinking as the single most desirable attribute for graduate engineers. This is massive. It is a shift away from technical know-how to knowing how to think about problems. No longer can we rely solely on our capacity as engineers to have technical skills. Now we need to know how to do engineering, but also how we approach our engineering as engineers. In other words, by thinking critically, we know how to discern the difference between a complicated and complex problem. Therefore, what kind of solution is warranted as follows. As an engineer, I was required to solve unexpected problems and think outside the box, often at a moment's notice, and you will inevitably be required to do the same. So what is involved in critical thinking? This infographic is adopted from the American Philosophical Association Delphi Research Report, in which a panel of experts sought to define the essential elements of critical thinking. As we can see, critical thinking is an extensive process, starting with interpretation and ending with self-examination and self-correcting. Now that you have seen this graphic, what do you think are the key features of critical thinking? Please take a few minutes to reflect and write down your answer and justification. We will use this to inform a face-to-face session next week. When you are ready, post it to the forum here. Go ahead, I will wait. In this video, we discuss the idea of applying critical thinking to our complex problems. In the next video, we will engage with value-based thinking and its relationship to complex problem solving. Here we will discuss how and what we attribute values to and their effects on complex problem definition. As a reminder, be sure to check out the resources folder on critical thinking. Please, it's a treasure full of gold. Indulge. Thanks for your time, and I look forward to continuing the conversation. See you next time.